We're going to be talking about proportional relationships today and figuring out how those relationships are related to what's called a proportionality constant. Proportional is of a variable quantity having a constant ratio to another quantity. Relationship is just between two variables. So if you put proportional relationship together, you're getting two variables and you're trying to figure out what the constant ratio between them is. There are two main types of proportional relationships that we're going to be using. The first one is a direct proportional relationship, and the second is an inverse proportional relationship. With a direct proportional relationship, that's just a standard linear relationship, y equals mx plus b. So with this equation, the m represents the slope of the line, the b represents the y-intercept, and I'll show you how to find that on Google Sheets. So when the line of best fit is linear, you have directly proportional variables. So as one variable increases, so does the other. As x increases, so does y. The second type of relationship is a non-linear relationship, which is called an inverse relationship. So in this situation, as one variable increases, the other variable decreases. So you can see on the graph you have quantity on the x-axis versus price on the y-axis. As quantity increases, price is decreasing. So in this situation, in the equation, it says y equals k divided by x. That k stands for a constant. So the constant, simplified with the letter k, is a relationship between the ratios of the two variables, which defines proportionality. So for direct relationship, k is proportional to x divided by y, and for an inverse relationship, k is proportional to x times y. Here in my Google Sheet, I have some density data. So this density data is the density of water. The density of water is 1 gram per milliliter, and what that means is that the mass is equivalent to the volume. So if I have 10 grams of water, I have 10 milliliters of water. So here down at the bottom, I'm showing you the relationship in terms of proportionality. So K, or the proportionality constant, is equivalent to x divided by y. And so what I did was I'm going to take in my equation equals x divided by y. Enter. And you can see that the data is pretty clean numbers. So what I'm going to do is I'm just going to drag this down all the way, because 90 divided by 90 is 1, just as 10 divided by 10 is 1. So when you have a proportional mass and volume, you're going to end up with the same density. So this column right here, the K column, shows you that no matter what, mass divided by volume will always equal the same density if you're dealing with the same substance. So I'm going to show you how to graph that in Google Sheets. So what you need to do in order to graph this relationship, to get that linear relationship on the graph, is you need to highlight your mass and volume data. So when you have that highlighted, you go over and you click on the Insert Chart, and you want to get a graph that shows the linear relationship. So this looks pretty good, and I'm just going to press Insert and move that over. So this clearly shows that I have a linear relationship for density, which is measured in mass divided by volume. So density is K in this situation. So K equals density, which equals x divided by y. Because every single time you divide x by y, you get the same value, which is 1 in this case for water. So then I want to show you how to find, because the equation of a line is y equals mx plus b. Using Google Sheets, how are you supposed to know what m, which is your slope, and b, which is your y-intercept, how do you find those? So specifically in Google Sheets, what you would do is you would, in an empty box, you would press equals and then start typing in the word slope. So Google Sheets knows that slope, it knows the equation for that. And so then what you have to do is you have to highlight your data one column at a time. So I'm going to highlight my volume data, just the values, press comma, and then highlight my mass values, and then close my parentheses. That's how you would find the slope of a directly proportional graph. To find the y-intercept, it's the exact same equation, except you would press equals, intercept. Google already knows that's what I want, so it pops up with intercept, and then I highlight my y data, comma, highlight my x data, close the parentheses. So now I have all the variables for the equation of my line. So let's say that I want to find an unknown value. If obviously this data is fairly simple, so let's say that I want to find, let's say I have 25 grams, and I want to find what volume that is. If the numbers were more complicated, this would be more relevant. So we can assume that it's going to be 25 milliliters, but let's just pretend we didn't know that. So I can plug it into the equation y equals mx plus b. I'm solving for y because volume is on my y-axis. So y is going to equal m, which is 1. I just found that. And then my x is the mass, so that's 25 grams. And then plus my intercept, which is 0. So when you come up with that, 1 times 25 plus 0 is going to equal 25. So that means my y equals 25, which makes sense because 25 grams divided by 25 milliliters is going to get you 1. So that's how we'd use the equation of the line in order to determine an unknown variable somewhere on this line, because anywhere on this line on the graph, every single point on this line, your density is going to equal 1 because of that proportional relationship. The second relationship is the inverse relationship. An example of this would be Boyle's law, which is a gas law. So gas law has determined the behavior of gases, and specifically for Boyle's law, the relationship is between pressure and volume. So it's considered the pressure-volume law. So in this situation, I have my pressures, which are measured in what's called torr, and then I have my volume measured in milliliters. And you can just see, looking at the data, these numbers are a little bit more complicated than my last data set. So just looking at my data, I'm going to say that my pressure as I go down the column is increasing and my volume is decreasing. And the definition of an inverse proportional relationship is that as one variable goes up, the other goes down. So in this case, my pressure, which is my x, is going up, and my volume, which is y, is going down. So let's find the proportionality constant and see if this actually is proportional. The relationship is that as one variable goes up, the other goes down. So in this case, my pressure, which is my x, is going up, and my volume, which is y, is going down. So let's find the proportionality constant and see if this actually is proportional. And so for an inverse relationship, the proportionality constant is equal to, equals, see they're multiplied together, so x is multiplied by y. So then all I have to do is figure out the proportionality constant, so I'm going to press equals, and I'm going to press my x, multiply it by my y. So when I figure out what x and y are equal to, you notice that they are all hovering plus or minus decimals around 380,000. So the ones that aren't exactly 380,000, that's because there's a decimal on the pressure, so it's not quite rounding completely. And so what I would do is I would just say, with the proper decimal rounding, that these are all proportional to the same value. Like that. So you notice that every time, plus or minus rounding, this is constant. That's what a proportionality constant does, is it shows you the relationship between two variables. So as I increase my x, I'm decreasing my y, but I'm doing it proportionally so that every single time it equals the same value. So I can make the assumption that every single place on this line the proportionality constant is equal to 380,000.